Day. All of you have had a nice lecture session as well as hands-on session, and a lot of participants are having issues, and we have tried to solve all those issues. However, still some issues are persisting, and I will request all of you that don't bother about the practical issues, as this is my responsibility that I will ensure that all of you will complete the assignment. Okay, so please keep confidence and keep faith, and whatever we are trying to continue in the practicals and hands-ons, you try to complete it within that, and beyond that also within your own system you can continue the practical assignments. And any issues during the hands-on classes, hands-on sessions, you can please don't switch on your microphones because it may create noises. So just you can put the messages, not in WhatsApp, but in the Google Meet chat. You can put your queries, and we will answer all the queries. All individual queries will be answered. I am making it sure. So today during the hands-on classes, Miss Lucina and Miss Swasini Pradhan will be continuing, and all the queries you are putting in the chat section, I will be answering all the chats during that session. So don't bother about the hands-on classes right now. Now we will be continuing. I have actually in the pre-launch session 2 lecture sessions are there, and in between that one half-an-hour break is there. So we'll be continuing with that. So in the first session, we will be covering the data component and software component, and in the second lecture session, we will be continuing with the GIS tools, the processes. So before that, I have already made it clear that all of you please don't bother about the practical hands-on classes, and that will be continued. And even this GIS hands-on classes on QGIS, those who are not able to complete the assignment, I am making it sure that it will be repeated, it will be reviewed. In fact, the review of the yesterday session will be done for 10 minutes, then we will continue the new assignments, it will continue, and at the end of 4th day, I ensure you that all of you will be able to complete the assignment. Means I will take 3 maps from you, which you have designed, and you will have to you will have to enter the data, generate the layers, and you will have to design it. Clear? So we'll discuss all these things in the hands-on classes, and please send your queries through chat only. I will answer each and every query, no problem. Okay. Now let us start with our lecture session. So, as yesterday already we have discussed, I'm just sharing my slide. You see, is it visible? Is it visible? Slides? Okay, good. Take the attendances. Okay, after 10 minutes, you take the attendances. Okay. So I hope everybody is able to see the slides. Well, you just check it whenever the slides are not visible or audio is not clear, just make me aware. Okay. So, yesterday, we have discussed certain basic concepts, key terminologies regarding GIS, and the definition of concepts regarding GIS. Okay, so this is the slide through which you can describe the whole GIS, its components and concepts and tools. This is a single slide through which you can describe whole GIS. So what is GIS? Already we have discussed. GIS refers to Geographical Information System, And what is spatial, what is geographical, already we have discussed. And what is DSS, what is SDSS. SDSS stands for Spatial Decision Support System. DSS stands for Decision Support System. All these are similar, same to Geographical Information System. Okay, so why this Geographical Information System is also called a Decision Support System? Because this is an information system. What is, in fact, what is information system? Already we have discussed. It has come from information technology. So in this information system, you see this computer hardware and software. This is the part information technology. This is the technology. This is the technology which gives you information at the fingertip. Any information, any kind of information you require, you need in day-to-day life, in large-scale planning, in small-scale planning, in any subject or discipline, you need this technology now. In medical science, in engineering sciences, in social sciences, day-to-day life, in shops, the shopkeepers without computer they cannot maintain their accounts and stock list. So now this technology is such a technology which has entered into the household of our life, and in day-to-day life we are using it. Why? To store data, to store information, to get information at the fingertip, to access information so that we can plan, we can handle the, we can manage the various real-world problems. Okay, so this technology, as this technology gives you information, that's why this is called information technology. And this whole system means this technology along with these processes is called the whole information system. And geographical information system, more refined way, it is called geographical information system because it is pertaining to the various objects and phenomena on Earth's surface. So now let us discuss something about the various components. As I have already discussed yesterday, the computer hardware, nothing in detail to be discussed here. The most important part, personnel, yes, we don't need to discuss about this because we are the personnel, we are the experts and users. The two important aspects which we are going to cover up or discuss within this lecture sessions is software component and spatial data component. First, let us enter into software component. What are the softwares? What are the types of softwares? GIS softwares. Then we will go to the GIS tools, means GIS processes and the tools available within the software for carrying out these processes. Four category of processes. So let us start with software. That is the GIS software. Software in general, it is an integrated collection of programs or a set of instructions. So in lecture, am I going a little faster? I think in the hands-on classes, as some of the participants yesterday told me, and that it is becoming a little faster. So we are trying in the hands-on classes to make it slower, as well as we are trying to repeat the processes so that you can get the hands-on sessions. Well, what is a software? It is an integrated collection of programs or a set of instructions. So all these programs are written in computer readable language, means computer cannot understand our language. Computer reads in its own machine language or programming languages. So I am not entering into the detailed technicalities of these software aspects or computer engineering aspects. I am just making it in a broad way. I am just making you understand. So all these softwares can be classified into three categories. One is system software, one is application software, one is service software. And system software, the software developed to run the computer itself. That means to provide a platform for running of application softwares. That means in the system, when I will put my computer hardware, will it automatically start? No. If I will power on, an operating system starts it, boots it, means the machine needs an operating system to operate the system. So that is the system software. And then application software, the software developed to perform specific tasks as per the user requirements. Like Most of you are definitely using word processing softwares. Image processing softwares means photo editor. Definitely all of you are using, because in your smartphones, what is the operating system? It is Android. So the operating system is Android. Once Android is loaded, the other apps you are loading, different apps for different purposes. So these apps are application softwares. That's why these are called apps. So word processors, definitely all of you are must be using, because for creating a word document, creating a thesis, creating a biodata resume or CV, you need a word processor, because word processor software is meant for processing the words. That's why it is called word processing softwares. Just like Microsoft Word, PageMaker, these are word processing softwares. And image processing softwares for editing photos or images, like Microsoft Photo Editor, Paintbrush, Adobe Photoshop, CorelDRAW. These are some photo processing softwares. Many more softwares are also there. And these are for photo editing, image editing, means raster image editing. As already yesterday we were discussing, those people who were not able to open these JPG files, JPG is a raster image format. If they want to convert it into TIFF format, you need a photo editor, because this is a photo or image. And GIS is an application software. For geographical information system or geographical information handling, we need GIS software. So GIS is an application software. So the softwares developed to perform specific tasks as per the requirements, as per the specific user requirements, are called application softwares. So now we have got what is the system software, what is the application software, and next is service software. These are the auxiliary softwares. Auxiliary softwares are called drivers, assemblers, compilers, or loaders, which help us run the peripheral devices like your printer. When you will bring your printer, a printer you will bring to your house and you will install it. Will it run automatically? No. A CD or a driver in a pen drive, you have to bring and install it. Most of the drivers are now, printer drivers are also now available in the website internet. So you have to install its driver, a gaming device or any other device. You have to install a driver and you have to run that driver so that the peripheral device can run. So this is the GIS software. And as already we have discussed, GIS software is an application software. It is an integrated collection of computer programs which encapsulate geographic processing functions and built in the on the foundation of a computer operating system. Most of the GIS application softwares are now available based on Windows and Linux. GIS software vendors, the various companies are there. The most important GIS vendor company which develops the #1 GIS package is ESRI, Environmental Systems Research Institute, Redlands, USA. It is from Redlands, USA. It is called ESRI, and it develops the most widely used GIS software, that is ArcGIS, ArcView, ArcInfo, ArcGIS. The whole package name is ArcGIS. So evolution of GIS software. Before 70s, very simple application were performed. Every GIS was unique as they were newly introduced. Very costly and resource scarcity was there. Between 1970s and 80s, GIS market grew up. Higher level applications on demand, standard user interface in command lines. Now I am coming to user interface. How a GIS software is structured. We'll come to that. So between 1970s and 80s, GIS market grew. Higher level applications on demand was there. Standard user interface was there. The command line interface, no graphical user interface was there. Just now, as you are looking into the QGIS, the graphical user interface is there. Earlier, it was not there. The command line interface was there. And within that, you have to put the commands, you have to memorize the commands, you have to put the command, then the activity will be performed. It's just like more like a toolbox. In late 80s and 90s, more advanced, easy to use and more generic softwares were developed. Is the audio clear? Okay. And command line interfaces were supplemented by graphical user interface, menu driven. So whether any chat queries are coming up? Is it there? So I request all the participants not to put any chat queries in the chat during the lecture sessions. In fact, all the queries in the chat you please put in the hands-on session so that I will be able to answer all the queries. And in this lecture session, is it clear? Screen sharing is coming. Or screen sharing is not coming. There also. See whether the screen is coming or not. Screen sharing is coming, no? Okay. So I'm just sharing the screen again. Okay. I'm just taking care of. I am sharing the screen again. Don't worry. You just update me whether the screen is coming or not. Okay. Is it coming? And you go through the chat and any problem if somebody is not able to see the screen or not able to listen the audio, then please inform me immediately. Okay. Now screen is coming? Yes. Okay. Good. So please, I request all the participants, if you are unable to see the screen or audio, then immediately chat me so that we will take care of it. Okay. So during late 80s and 90s, more advanced, easy to use and more generic softwares came up, and command line interfaces were supplemented by graphical user interface, menu driven. Customization capabilities were added to allow specific purpose application from GIS software. Okay. Yes. New items were developed, land information system, planning information system, automated mapping, facility management came up. And beyond 90s, the advancement in GIS came up, like intelligent systems, export systems, web-based GIS, internet servers, integrated facility for raster and vector analysis. Now let us come to structure of GIS software. Is it coming? Okay. So structure of GIS software. So you see, it is a three-tier architecture. GIS software, it is having a three-tier architecture. Unlike other softwares, you must be having various application softwares. All of you must have used a lot of various types of softwares. You are engineers or mostly you are professionals, so you must have used like AutoCAD. The engineering persons, they must have used AutoCAD or MATLAB or many softwares. Microsoft Word, PowerPoint, Excel, or Adobe Photoshop, Adobe PageMaker, or Adobe Reader. So these are different application softwares built for various specific purposes, specific application purposes. In all these softwares, nowadays you are getting an user interface. Means whatever you want to carry out any function, can you tell just the computer verbally and it will listen and it will perform? Yes, nowadays voice recognition systems have been developed. Yes, this is the advancement. But earlier it was not the case. Earlier, the only command line interface was there, which was the mediator between the computer and user. So user interface is the mediator between the computer and the user. So in the command line interface, you have to put the commands on the black screen. You have to put the command. Then whatever the command you have given, that activity will be carried out. Just like you want to copy a file, you have to give a command copy, copy, then file name. Then the file will be copied. Then paste, you have to again give the command paste, 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 then the file name, then it will be pasted in the desired destination. So it was the user interface. Then now, actually, you all are having the softwares with graphical user interface. Graphical user interface means the user interface is characterized by graphical icons. The graphical icons are there. It is displayed. If you want to cut, a scissor symbol is there with a button. On the bottom, the scissor symbol is there. If you click that icon, the cut operation will be performed. You don't have to give the command in the you don't have to type the command. You don't have to memorize the command and type the command. You just click on the button, it will be operating. So this is graphical user interface, and nowadays advancements, the voice recognition system has come, and if you will just tell something verbally, the activity is being performed. How? In fact, whatever we are telling verbally or whatever we are clicking on any button, behind that, a program is being linked in the computer readable, computer understandable language, so that computer understands that this cut means I have to cut something and paste something. So a program is being linked to all these buttons. Then the second tier is tools, the functionalities, the utilities for performing required geospatial processes. So all these functionalities and utilities for performing required geospatial processes are being provided in this GIS system through these graphical user interfaces. So tools, these tools are the second tier of this GIS software. And the third is database management system, DBMS, the management of attribute data plus spatial data with query support, standard query languages support. And this is the specialty of GIS software. So this database management system is the uniqueness of a GIS software. You see, most of you have used various graphical packages like AutoCAD, like photo editors, image editors, and like Adobe Photoshop or Microsoft Photo Editor. Yes? Is it coming? Any chat is coming? Well, so the third tier is database management system, and this is very important. This makes the GIS unique from other application software. In fact, as already I was discussing, you must have used graphical packages as well as database packages. Like various database packages are there. Though Microsoft Excel is not a database management system, but you must have used, definitely all of you have used Microsoft Excel. So in Microsoft Excel, what happens? It is a spreadsheet. In this, you can manage data. Large number of volume of data you can handle here. You can enter, you can play with this data. You can analyze, you can create graphs, charts, everything. But whether this data is linked in Microsoft Excel to some graphics, is it so? No. In AutoCAD, you can create graphics, graphical geometrical shapes or graphical shapes like point, line, polygons, various kinds of polygons. But whether any database is linked in AutoCAD. Nowadays, some advancements have come up in AutoCAD also to link external databases, but there is no integrated internal database management system in AutoCAD. But in GIS packages, it is the uniqueness of GIS package that database management system is already integrated, inbuilt in GIS along with the geometrical shapes or graphical layers. So how? I will just explain it. So as already I have discussed, there are two kinds of user interfaces. The first tier of the GIS software architecture or the software structure, the command line interface as well as graphical user interface. And nowadays graphical user interface predominates. Most of the softwares are having graphical user interfaces, but still in certain softwares like AutoCAD and certain GIS packages, command line interface is still there in order to provide our own inputs. So this is a sample of old Arcgis 3.5.1 version in which this command line interface is there. Is the video clear? The slides? Yeah. Okay. And audio is looking okay. So this is old Arcgis 3.5.1, and you see the command line, command prompt. And here, a graphical, this is the CGI, common graphic interface. And through this, the graphical, the map is visible, but in the top, the command line interface, the interface is there, where you have to put the commands, you have to type the commands, and the concerned activity will be performed. It was the old system of GIS. Now this is the graphical user interface. And in graphical user interface, what happens? You see, a menu bar is there, in which menus are there. I was discussing yesterday what is a menu, just like you are going to a restaurant, in a restaurant, and you are having a menu card in which all the activities have been listed, all the dishes have been listed. Here, similarly, in this GIS package, all the activities, whatever is feasible in this GIS package, have been listed in this menu. So under the view menu, a lot of things have been listed, but whichever is not applicable now, it is in gray, and whichever is applicable, it is active. You can see. So this is this encompasses all the activities listed in this menu. Next is button bar and toolbar. Already I have discussed what is the difference between button and tool. Tool, you have to click on the icon and you have to take that tool to the place of activity. But in button, if you will click, this is a zoom in button, zoom in, zoom out button. But the zoom in, zoom out tool in our view will be coming somewhere here, and you have to click on that zoom in tool, and you have to take that tool here and draw a box so that that particular box area will be zoomed in. But if I will click on the zoom in button here, the zoom in will be automatically performed here. The whole area, whole map will be zoomed in. And this is a table of content, and this is display window in GIS, because in all GIS packages there is a display window, because we must visualize the maps, otherwise we cannot work. So any GIS package you imagine, you just take for the activity, you will get a display window for display of the map, as well as a table of contents. This is the table of content in which all the layers have been listed. You can switch on, switch off, and you can work on the layers here. So, database management system in GIS. A database management system, but why it is required? It organizes data, it stores large volume of data, it facilitates easy updating, retrieval at will, and it facilitates logical queries. A GIS software is accompanied with inbuilt or shared DBMS, as it handles spatial as well as attribute data. Means GIS package is unique. It handles the graphics, the geometrical shapes, the graphical data, along with a linked or indexed attribute database. So the attribute data is linked to this spatial data. And now let us come to types of GIS softwares. Is it coming, the screen? Okay. Okay. Any audio is coming? Sound? From that side? Maybe. Some music is coming on, just check it. So types of GIS softwares in the market. These are some important types of GIS softwares you must know. So the first is professional GIS, then desktop GIS, then handheld GIS, then enterprise GIS, then viewer GIS, component and modular GIS, internet GIS or web GIS, R2V softwares, raster to vector. R2V means raster to vector software, and image processing systems, export systems. So these are the various types of GIS softwares. Recording is going on. Yes. So these are the various types of GIS softwares. Now I'll just explain a little bit on this. So what is a professional GIS and what is a enterprise GIS? What is a handheld GIS? What is a desktop GIS? What is a viewer GIS? So most important is professional GIS. Just like if I will tell you are a professional engineer or professional doctor, means a professional doctor or a professional engineer and a trainee doctor or a trainee engineer. There is a difference. What is the basic difference between a trainee and a professional? The basic difference is professional knows most of the engineering aspects, engineering knowledge. Means if I will tell a professional civil engineer, he must be capable of monitoring, supervision, carrying out designs, all the civil engineering activities he must be able to carry out. If not all, at least most of the civil engineering activities he must be capable of. So, if a person is capable of carrying out most of the civil engineering activities, then he is called a professional civil engineer. And a student or trainee civil engineer, he is in the learning phase. Trainee in the learning phase. He knows less than a professional civil engineer. So, a professional GIS means that GIS which is having capabilities, most of the GIS functionalities or capabilities inbuilt within it. What are the functionalities? Already we have discussed. Various processes can be categorized. Various GIS processes can be categorized under 4 categories. What are those categories? The number 1 is the input modeling and storage category of functionalities. The number 2 is the database, data editing, management and manipulation capabilities or functionalities. Number 3 is spatial analysis, the geographical analysis capabilities. Number 4 is the cartographic presentation capabilities. Okay. Some participants, I hope, have switched on their microphones. Please switch off all the microphones. All the queries we will be answering during the interactive session after during the last 15-20 minutes. During that, you can put your queries in the chat form and we will answer. Okay, I will answer. So some music was coming up, so I request all the participants to switch off their microphones. Well, so as I have already discussed, professional GIS. So this is a professional GIS means it encompasses most of the functionalities. Means within that particular GIS software, if it is a professional GIS software, then within it most of the facilities, functionalities are available under 4 categories. All 4 categories. All 4 categories means number 1 category is data input modeling storage. Number 2 is data editing management manipulation. Number 3 is data analysis. Number 4 is data presentation capability. However, certain GIS packages are there which are having only 1 category or 2 category of functionalities available. Like data input modeling capabilities are only available. Means we can digitize, we can vectorize, we can generate layers, but we cannot analyze. The analytical capabilities are not there within a package. Like there is a software R2V, its name. It is only an input data input software. So these are called R2V software or modular packages. Means a particular module or a particular category of functionalities are only available. But what is a professional GIS? It is having all the 4 category of functionalities. And as much functionalities are there under each category, the GIS is that much powerful. That's why some GIS, professional GIS packages are very powerful and they are occupying the most of the market. And some GIS professional GIS packages are not well appreciated in the market based on the number of functionalities they are available under each category. So, what is the difference between professional GIS and an enterprise GIS? The basic difference is enterprise GIS and professional GIS both are having all the 4 category of functionalities. Means enterprise GIS is having all the capabilities which a professional GIS should have. But additionally, the enterprise GIS is having network compliance. Means we can use this network GIS, the enterprise GIS in a large network, large organizations. So the same facilities are there in professional GIS as well as enterprise GIS. The GIS capabilities are not different, but network compliance makes a GIS package enterprise GIS. So if you are having a big organization like TCS or some big organization in which hundreds, thousands of people are working simultaneously, simple professional GIS installing in standalone systems will not work. You need an enterprise GIS which can be installed in the server and everybody can work in terminal ends and it will be network compliant. So that is the basic difference. The enterprise GIS is a professional GIS which is network compliant. And what is a desktop GIS? It is also just like a modular package. It does not have all the 4 category of functionalities. On the desktop, we basically need the data analysis capabilities as well as the data presentation capabilities. And the software GIS package, which encompasses these facilities, are called desktop GIS packages. On the desktop, whatever we need, the presentation capabilities, the data analysis capabilities, and the backend data generation, data input, modeling, storage, data editing management. These facilities may not be there, or if these will be there to limited extent. So that software will then be called a desktop GIS. And what is a handheld GIS? The handheld GIS refers to the GIS packages available which can be loaded in palm-top computers or the smartphones, because these are handheld devices. So in handheld version, what is the basic difference? So as all of you must be using smartphones. I hope all of you are using smartphones. In these smartphones, most of you must have used Microsoft Word, or let it be any word processing software. So what is the difference between the Microsoft Word loaded in a laptop and in the mobile phone? What is the basic difference? So if you have experienced, I hope you can very well understand the basic difference. The basic difference is in the desktop version or in the laptop version of the Microsoft Word, most of all the functionalities for word processing are there. But in the handheld version, in the mobile or in the palm-top computers or in the tablets, the handheld version of the Microsoft handheld version of the word processing software, most of all the facilities whatever available in the desktop version is not available in the handheld version. In the handheld version, only most frequently used functionalities are available. So that makes it handheld GIS. Just like cut, copy, paste, bold, then italic, all these frequently used facilities are there. So what is a Viewer GIS? These are the promotional packages developed by various companies. Viewer GIS. Viewer GIS means it's a GIS package in which it cannot work. Only you can view the developed GIS layers or files. And component and modular GIS packages. These are specifically modular packages or specific small packages which are designed to perform particular GIS activities. Like if I want to develop digital elevation modeling or 3D modeling, a particular 3D analyst module may be there available in the market. If you need 3D modeling, 3D analysis activities, then you can purchase it. Otherwise, you don't need it. Internet or web GIS, nowadays it is the advancement of GIS. If we are able to develop dynamic systems like GIS, we must be able to upload it in the web also, so that on the website also all the GIS facilities will be there. So nowadays web GIS is also there. And image processing system, and the last one is image processing means raster image processing softwares. Most of the GIS packages are vector GIS packages, but image processing package is a raster image processing software in which raster analysis can be carried out. We will discuss later on what is a raster and what is a vector. So the last one is export system. And what is an export system? It is specially designed to carry out a particular export-based activity. Like, I'll give you an example. I'm just coming up. What is a professional GIS? Now, already we have discussed a professional GIS are high-end, fully functional systems. The term professional relates to the fully featured nature of this class of software. In other words, most of the utilities, tools that a GIS should have are available in this. Just like Arcgis from ESRI, Mapping for Professional, Geomedia, Probe, Small World GIS, AutoCAD Map, and we are using in the hands-on the QGIS or Quantum GIS. This is a professional GIS package. Most of the GIS functionalities under each of the 4 categories are available in this. But the difference between Arcgis and QGIS is ArcGIS is a professional as well as enterprise GIS, but QGIS is a professional GIS only. Desktop GIS. The desktop GIS are the mainstream workhorses of GIS today. The focus is on data use, making maps, reports, charts, querying, etc., rather than database creation and analysis. So ArcView from S3, Mapping for Professional, Geomedia, Special Intelligence, these are some desktop GIS packages. Nowadays, in the internet, a lot of other open source GIS packages are also available, modular GIS packages or desktop GIS packages. Handheld GIS are lightweight systems designed for mobile and field use. With due course of dramatic miniaturization in hardware design, it has been developed to use in handheld and mobile systems. Somebody is having ringing mobile name. No? So, all the participants should mute their audio so that the noise will not be there. So the enterprise GIS, it is the professional GIS, already I have discussed, added with the database server engines. In other words, it is a combination of professional GIS with internet server, database server, and network compliance, designed for big companies and organizations. Just like ArcInfo plus ArcSD plus ArcIMS, it is professional GIS. Viewer Gis, already discussed. Viewer Gis is basically intended for display and query of spatial data. This usually supports all popular file formats. Most of the companies launch it as a free to promote their products. Internet GIS mapping, display, and query integrated with web browsers and servers. This uses hypertext transmission protocol for communication, focuses on simple display and query applications on the web, enhances the easy access of data in the internet. Component or modular GIS, these are toolkits of some similar application tools in a single module. Combining the different modules for different applications, a full-featured GIS setup can be established. Just like 3D analyst, spatial analyst from ESRI, raster to vector GIS. These are specifically designed for data conversion from raster to vector. These provide manual on-screen vectorization facilities as well as automatic tracing facilities. But the vector files created in this chapter need to be edited as our source maps are usually dirty and wrinkly. So we'll discuss during data input tools, we'll discuss in detail regarding this, but we need to convert raster to vector because most of the GIS packages are vector softwares. Then image processing, most of these are specially developed for satellite image processing. These are also because satellite images are raster images. They are not vector. They don't come in vector format. But most of the GIS packages we use are vector format softwares. So we need to convert these satellite images with manual interpretation or digital interpretation into vector formats so that it can be integrated with other layers in our GIS. These also provide all facilities for raster GIS analysis. Some vector processing facilities are also available in these raster image processing softwares. Just like AirDAS, imagine it is a raster image processing software in which also GIS facilities are there. The AirDAS means Earth Resource Data Analysis System, ERDAS, and various other softwares are like in there. The open source software like ILWIS, ILWIS, it is open source. You can download it. The last one, ILWIS. Yes, this one, ILWIS, Integrated Land and Water Information System. It is open source software. And the last one is export systems. These are designed with inbuilt intelligence or rule bases for performing specific analysis tasks in application fields. The logics, intelligence, rules for analysis is incorporated in software in the form of menus or options. Just like I will give you an example, the Mike 21 or Mike 11 from DHI. This is Danish Hydrological Institute. They have developed a lot of modular packages. These are all export systems. Like Mike Basin is specifically meant for watershed management. Mike 21 for hydrological modeling. So export system. So what is an export system? Means let us, you have QGIS. In this, you can customize. You can customize this. You can program based on programming. It is a Python-based software. So through mild programming, you can modify its interfaces, and you can add some buttons in ArcGIS also, or view. Through customization, you can add some buttons, some tools specifically designed for carrying out your own desired activity. Like, let us, we want a groundwater prospect solution. Okay, so for knowing groundwater prospects, where is good groundwater prospect, which location is having good groundwater prospect, and which location is not having good groundwater prospect. How to know this? Various criteria are there, based on lithology or geology, based on availability of lineaments, based on soil category, based on drainage, based on proximity to drainages, natural drainages. If I will put all these rules in customized form, in buttons, linked to the buttons in a particular GIS package, and then I will add all these layers for a particular location and click on that button, automatically my good groundwater prospect layer will be generated. This is an export system. So we can incorporate our rules or intelligence or logics which we are having or we are inputting into the system. These rules can be framed through a program, through customization in terms of a button or menu within the particular GIS package. These are advanced aspects. And after incorporation of this logical rule in the form of a menu or button, this GIS software becomes export system. And this example is Mike 21. It is a specially designed hydrological modeling software. So this is an export system. So various products from Arcgis company, various products are there. Arcgis. These are some modular packages: Arc Network, Arctin, Arc Grid, Arc Pogo, Arc Scan, Arc Press. This is the old Arcgis version, 3.5.1 with command line version. So various add-on modules, modular GIS packages for ArcView. This is the interface of ArcView. This is a handheld GIS. You can get a glimpse. This is a palm-top computer in which ArcPad is loaded. This is a handheld GIS. And all of you are having smartphones. I hope all of you are having smartphones. And the operating system in this smartphones is Android system. So nowadays, from QGIS, a Android version of QGIS is also available. That is a handheld QGIS, which you can load in your smartphones. It is freely downloadable. So this is interface of GeoMedia. This is map info interface. More or less, the interface is similar for all the GIS packages. So in GIS, the software doesn't matter. You can launch the software just like a TV remote. If you are bringing a TV, television set, new TV to your house, and the remote, the complicated remote. I hope all of you are getting able to understand. Or what about you? A small child in your family within 3 or 4 years nowadays can very well understand the TV remote within 1 hour, because it depends upon the acquaintancy or what is your attitude to learn this new technology. But the concept is important. How to operate. The software you can learn within 10-15 days, no problem. Any GIS software. Once you are working with QGIS, means you can work with any GIS software, no problem. But you must know the concept. Because let us, an analytical concept is buffering. If buffering, you know why buffering, how buffering is done, and why buffering is required, where to apply buffering, then the buffering options and buffering term will be same in all the softwares. In most of the softwares, the buffering is written buffering, and you can click and you can have your buffering. So this is another handheld GIS from Autodesk company. There's some problem. Has developed one GIS, ISRO GIS, ISRO GIS, ISRO GIS, and NIC has also developed GISNIC, GIS NIC. ILWS is an open source GIS package. All of you can download. It is image processing software. You can process satellite images here. Remote sensing software. This is AirDAS Imagine module. So this is something about types of various GIS softwares in the market. We have discussed various softwares types are professional GIS, desktop GIS, handheld GIS, enterprise GIS, Viewer Gis, Modular Gis, R2B, image processing systems, and export systems. I hope most of you have got clarity regarding this. At the end, we can, if you have some query, you can put some queries. Whether some queries are coming up. The queries we will be answering after another 3 minutes. Okay. Well, now let us come to this. Now we have got already the software component, types of software. Let us come to data component of GIS. So prior to that, we must know the data structuring. Well, I'm starting now the data structuring. So this is most important. Actually, this is most important before hands-on work. Already we have started little hands-on work, but today you will be developing some layers in the hands-on classes. So prior to that, you must know the data structuring. Is it clear? The screen is coming up. Okay. So as already we have discussed, spatially referenced data. What we are going to deal with in GIS, geographically referenced data or spatially referenced data. Means data related to spatial objects and phenomena, isn't it? So we are going to deal with this, like the rainfall, the temperature, the pressure, the hills, the mountains, the roads, the locations of hospitals, police stations, the location of various population, the districts, the blocks, the villages. These things we are going to deal with in GIS. Well, if some events are going on, where, as I have already told you, I need from all of you all the assignment yesterday we have discussed, that is georeferencing. You have georeferenced Orissa map. You have found 5 locations, their coordinates, their distances from Bhubaneswar, and you have put those coordinates on Google Earth image also to validate whether you have taken the right coordinates, whether your georeferencing process is correct or not. And then I have told you already to record your locations, means where you are, your place location. That you have to email also along with this assignment. So why this is needed? In the last class, I will explain you. We are going to carry out a project of your location. So how to take your coordinate or location? How to define your location? I don't know all of your places. Wherever you are sitting, wherever you are sitting, if you are sitting in a small village of any place. So if somebody is staying in Odisha in a small village, if somebody is staying in Maharashtra in a small remote village, I don't know all the locations. So how to know the various locations? So I need your absolute described location. That is the coordinate of your location. How to take it? You can locate yourself by a GPS app. If you have a GPS, you can take your coordinates. If you have a GPS application uploaded in your smartphone, then also you can take your coordinates by clicking on it. Or else you locate your place in the Google app and record the coordinate and send it to us. Well, so what is spatially referenced data? The data regarding our spatial objects of interest. Well, in our day-to-day life as well as in almost all subjects. Let it be a botany student. He or she is concerned about the forest species, flora species, and what kind of forest is there? Where? The basic question is where, the location. A civil engineer is concerned with dam. How to locate a dam? Where a dam should be constructed? Where? Again, the where. A medical student is concerned with the spreading of diseases, the surveillance of diseases. COVID, where it is spreading? Everywhere or at a particular location? If at a particular location, what is the pattern? Why at this particular location? That matters. Zika virus, where it is spreading? If in the Southern America, then why in that particular area? So, where the location is an important aspect of all these spatially reference data. So spatially reference data is having three basic properties, which is of our importance in GIS study. The first is position or location. Already we have discussed this yesterday. The position or location is the prime spatial aspect of a spatial data. How to describe this position or location? Already we have discussed. There is a relative description of location. There is an absolute description of location. And in GIS, we are concerned with absolute description of location. That is location in reference to a known coordinate system or global coordinate system, which is uniform for everybody. That is latitude, longitude coordinate system. In this latitude, longitude coordinate system, if I am describing the location of a particular person, as I have already told you, you please send your location in latitude and longitude so that anybody on this Earth surface, he may be in Australia, New Zealand, or USA, or Bhubaneswar, will know your exact location. So this is position or location. Then the second spatial aspect is spatial relationship. Means each spatial object is having a spatial or geometrical relationship with other spatial object or geographical object. This relationship is called topology or geometry. Just like I can, as already we have discussed, I can describe your location in the relative term, where you are. I am sitting in Bhubaneswar. Where in Bhubaneswar? In Bhubaneswar, near CRP Square. Near CRP Square, where? Near CRP Square, there is a plot number gas. Particularly, let it be plot number 305 or something like that. Within that plot, in the first floor, within a particular room. So, this is my relative description of location, and this is my spatial relationship with other objects. Means my plot 305 is adjacent to CRP Square. Where is CRP Square? It is within Bhubaneswar. In ward number, let it be 20. So this is spatial relationship. So a spatial object or phenomena is having a location and a spatial relationship with other objects, other spatial objects and phenomena. These two are primary spatial aspects of a spatial object and phenomenon. And the third aspect is attribute, means the spatial and non-spatial characteristics are associated with them. Like if a mountain I am talking about, if a forest I am talking about, the location and the adjacency are the basic spatial aspects. But what is the area of that forest? What is the type of that forest? It is a deciduous forest or a evergreen forest. The various characteristics associated with it, its canopy density, its number of trees, its in charge forest officer. All these are the other characteristics which are not spatial aspects, which are called non-spatial aspects. So a spatially reference data is having three aspects. One is three properties. One is location or position. One is spatial relationship or topology. Another is attributes. And we need to structure all these things. The attributes can be represented in terms of a table, but the location is represented in terms of geometrical shape. Like three symbols are there through which any feature in this real world or any event can be represented. That is point, line, or polygon. And this point and line and polygon is represented from the location or coordinates. And all other non-spatial aspects like area, its distance, color, shape, its name, all these things are the attributes. So attributes are getting represented or structured in terms of a table. But the location is represented in terms of a geometrical shape or the graphical feature itself. So GIS is unique as it integrates the tabular data as well as tabular data means the attribute data as well as the geometrical feature itself. Here you see the lines are there, the drainage lines are there. Each drainage line, if I will click, automatically in the table its linked attribute data will be selected. So if I am selecting a particular contour here, its contour value is 40 meter. So if I will select the table, automatically the same feature is also getting selected here. If I will delete it from here, it will be deleted from the map also. So there is a link, indexing. So that's why a GIS file, when we are creating a GIS layer, let it be this is a single layer, single file contours in GIS. But in the computer, in the My Computer Explorer, Windows Explorer, if you will find this layer, minimum 3, maximum 5 or 9 files will be created automatically. Because a table file is there, a geometrical shape file is there, a linking file is there, minimum 3. And based on projection of the other aspects, 9 files may be created. So that's why its database structure of a GIS file is very complicated because it integrates many things. But it makes it easy for us to manage the problems, real world problems and solutions. So we have to keep in mind this complexity of this GIS file. Now let us go to data structure in GIS. How this file is getting stored and structured in a GIS database. So it is a background matter in fact. So whatever layers we are creating, the computer is storing in its own way. That storing of the computer is called data structure in GIS. So we have spatially referenced data. It's two components. One is the attribute component, one is spatial component. Spatial aspect of the data, geographical data or spatial data is getting represented in terms of its coordinates, and the attribute component in terms of its tabular data. So the model or structure this data by modeling, by structuring. Because just like I will give you one example, if you have multiple files, you have hundred of files, your study files, let it be of different subjects, mathematics, science, social science, literature or languages. So 4 category of files, but 100 files. If we put all these files in a corner of your room, and I will tell you that give me the science file. The science file, 10 files are there. Out of that, I need the science file of 2020 year. So you will have to go and search all the 100 files in your room. But if you will organize all these 100 files by category, 4 category files are there. You will organize all these files under each category and put each category of files in a shelf. There are 4 shelves. Each category represents one shelf. So if I will tell you to find out a particular file, you will have to search only one shelf, not the 100 files or all the 4 shelves. So organizing or storing properly and facilitates easy access, easy retrieval, less time consumption, so and more accuracy. So this is the need of data structuring or modeling. And computer also can understand and access the data and retrieve for us in a very efficient manner. So as in GIS, we have spatially referenced data, which is having 2 aspects. One is spatial aspect, another is attribute aspect. The spatial data modeling is being done in 2 ways, raster modeling and vector modeling. And the attribute component is being modeled in terms of hierarchical, network and relational modeling. And most advanced aspect is RDBMS, relational database modeling system. Nowadays, Oracle you must have heard, That is a relational database management system. So let us come to first spatial component of data structuring, that is raster and vector data structuring. So this is the difference between raster and vector. You can very well see, is it coming? The screen is coming. Okay. So this is the concept of vector and raster data structuring. So you see, in vector and raster data structuring, the basic difference is, if I am concerned in the real world of a particular area, here a river is there, few houses are there, few other forest area and other forest areas are also there. Okay, so this is being represented like this in raster. In raster, the same area is being divided into multiple grids and multiple rows and columns. Okay, so each row is representing the particular feature. This is a river, this is house, and these are the trees. But at the same time, in the vector representation, all these features are being represented in terms of three symbols, that is point, line, or polygon. Either point or line or polygon. A hospital, you can, based on the scale of representation, and a hospital you can present it in form of a point, a police station, a point, a forest area, it is a polygon, a water body, it is a polygon, a well, it will be a point, a road, it is a linear feature, a river, it may be a linear feature, may be a polygon feature or area feature. If it is Mahanadi river, a major river, or Ganga river, it is polygon feature, based on the scale of representation, in fact. So in raster, the whole area is being divided into multiple grids and multiple grids. The size of grid defines the resolution of the representation. If the grid size is smaller, then the scale of the resolution of representation is higher. If the grid size is larger, the resolution of the representation is coarse. And it depends upon the size, as I have discussed, it depends upon the size of the grid. However, if I will increase the resolution by reducing the size of the grid, the file size will also be increased. Because you see, in this case, there are 10 rows and 10 columns. So 100 grids are there. If I will reduce the size of the grid into 1/4, how many grids will be there? So let us, each grid I will divide into 4 parts, 4 small grids. Then there will be 20 columns and 20 rows. So 400 grids will be there. So number of grids will increase from 100 to 400, 4 times increase. As well as the file size will also be increased. In vector representation, it is not like that. The line, simply it is a line. The coordinates of lines are getting represented, getting stored in the computer inside. So in case of a point, the coordinate of the point. In case of a line, it is a combination of multiple points, because a line, this is called a polyline. A polyline is a combination of multiple straight lines or segments. Each straight line is a combination of 2 points. A straight line is joining 2 points only. So if I will store the coordinates of these points, and computer will retrieve this line by joining these points. So it will store a table. So in case of a vector representation, the file size is very low in comparison to raster representation. So this is the example of raster representation as well as vector representation of the reality. You see, as I have told you, based on the grid size, how the resolution of the raster representation differs. You see, this is a very coarse resolution image. This is little higher, this is little higher, and this is the best resolution. But we have to select, we have to choose a combination of both. In fact, higher resolution as well as file size, because here, if the file size is 30 KB, here it will be 30 MB, 30 megabytes. So in between, we have to select a particular image so that in the raster representation, the resolution will be of our use as well as the file size will be less. And in the GIS softwares, there are facilities to convert the vector to raster as well as the raster to vector. And you see here, a vector line is there. If I am converting into raster, this is the raster representation of that particular road. No. Is it visible, the slide? Yes. And now you can also note down or you can get into this basic difference of vector and raster. You see, there's a comparison between raster and vector. And in the hands-on class, I will again explain this raster and vector because the Odisha map given to you, it is a raster format map. And today we'll be developing some layers: point layer, line layer, and polygon layer. And these layers will be in vector format. And ultimately, all the analysis, all the mapping we will carry out with these vectors. Now, you may put a question that if some map is existing, why to develop it again in the vector format? Yes, the answer is we are not developing the same map again. We are going to develop various layers so that we can analyze. Because in the given Odisha map, if I will tell you that find out the national highways, then in the next step, find out the 100-meter buffer zones of these national highways, so that whatever the villages coming within these 100 meters, I want to identify. Why? Because these are the most vulnerable, most pollution vulnerable villages, because they are within 100 meters of the national highway. So I want to identify. Can you do this? Because this map is in raster format, it is a static map. No changes can be made in this, and no individual line can be selected in GIS, and it doesn't have any table link to this. So no analysis can be made. But if we will develop the vector layers, means all the highways will develop as a vector layer, line layer, and the villages as point layers, then we can analyze. No problem, as I have already discussed. So this is the comparison between raster and vector. The most important comparison between raster and vector is precision. The vector is very much accurate and more precise, whereas raster is limited by the grid size. As I have already displayed, in the raster format, it is limited by the grid size. If the grid size will be smaller, it will be more precise, more accurate, more sharp. But in case of vector, if I am representing a river in form of a line or a road in form of a line, it is simply a line. Whatever the amount you will zoom it, the line will be a line only. In the hands-on class, I will show you in the raster Odisha map, whatever is given to you, it is already you have zero reference. If you zoom it, a road will be cracked into the pixels or grids, and gradually whatever larger size you will zoom in, the grids will be visible in much thickness. But in the case of vector, whatever amount you will zoom in, the line will be a line, simple line, sharp line. So precision in case of vector, it is more accurate, more precise, but in case of raster, it is limited by grid size. And the second is attributes, linkage to DBMS relations direct in case of a vector. And the outputs, the high quality and plotter scatographic quality. The vector layers, when we are going to bring out the outputs in the form of static maps, the JPG maps or PDF maps or printouts, there will be high quality output in comparison to the raster. And remote sensing interface, actually all the satellite images are coming in raster format. So in raster software, there is a direct interface for remote sensing. But in case of vector, all the satellite images need to be interpreted, converted into vector files, and then it can be used in GIS. So these are some basic differences between raster and vector. So now, if somebody is having some query, they can put some query, we can interact, and I will close it. But prior to that, just let me have, yes, another one slide I want to show right now. So this is something about data structuring, and just this one slide I want to cover in this session is database design. What are the various steps in designing a database? So it is applicable to GIS database as well as a standard database designing. So there are three basic steps. One is conceptual design, one is logical design, one is physical design. And as it is very much clear from the terminology itself, conceptual design. Yes, first you have to conceptualize what kind of database you need for your application. Means you want to solve a problem of dam site suitability analysis. So what data you need? You have to plan it. What kind of data? How dam will be located? What are the criteria for site suitability analysis for a dam? First, you should need, you cannot construct a dam on a road. You have to construct a dam on a natural drainage river. So you must have all the rivers of your state first. A layer, a map describing all the natural drainages or rivers. Then the relief, the second criteria is relief, the contour, because based on the relief, you will design the location of the dam. So several such criteria is there. You have to conceptually think of what are the requirements in your database. Then you have selected and thought of conceptually, but whether logically it is feasible, you have to design, you have to come to the logical design phase. What about the layers? What about the database specifications? You have designed, you have analyzed, you have to design it in logical phase. Means in logical design phase, database specification, database elements, database structure, database updating procedure, these things need to be defined properly. Means data elements means what are the particular layers and in which form. Let it be river in polygon form or in line form, road in line form or in polygon form. It depends upon the scale of representation. If you are preparing a 500-meter buffer zone of an urban area, particularly your place of location, if you are staying in a city and from your location 500-meter land use map, the national highway is passing through this area, then it will be taken as a polygon, because in 500-meter buffer zone, it is large scale mapping, it will be taken as a polygon. But if you are preparing the national highways of Odisha or your state, then this national highway will be taken as a line. So in logical design phase, you have to validate and design logically what will be the structure of your database. Then finally, the step is physical design phase. And in physical design phase, you will start implementing the logical design, the output of logical design phase, you will start implementing in the physical design phase. Means in this phase, you will start developing your database physically. Means you will start developing your layers, start developing your linking of attribute databases, and you will rectify it, edit it, correct it, and finalize it. So in this phase, hardware configuration, software characteristics, softwares, and database access design, all these things are important. So three phases are there in a database design. One is conceptual design, one is logical design, one is physical design, and these three phases are sequential phases. So I end with this, and if some participants are having some queries, they can put it so that I will answer it. My screen is coming up now. Yes. Yes, Kamala Kansau, you have put a query, is Internet GIS available free of access to public domain? What is the importance of GIS in groundwater modeling? Yes, in Internet GIS, actually most of the Internet GIS are not available free of cost. But nowadays, QGIS is an open source GIS, and associated with this, some Internet GIS is also there, which is available in public domain. QGIS is a software which source code is also in public domain. You can put a query if you want a particular aspect of application. You can put a query, and within 5-7 days, you can get the solution on the internet also. Somebody will develop it. So you can develop and also upload. So QGIS is an open source GIS in true sense. And the importance of GIS in groundwater modeling you want to know. So yes, it is very important in groundwater modeling. So I hope you are from the groundwater modeling field, maybe a civil engineer or geologist, hydrogeologist, but it is very important because in groundwater modeling, you need to integrate multiple layers, multiple spatial layers like geology, lithology, the natural drainage, the relief, and all this integration is very much feasible in GIS with very efficient manner. Because you just imagine, earlier, if I'll give you in hard copy 4 maps, soil map of Odisha, this lithology map of Odisha, drainage map of Odisha, integrate. How you will integrate? You will develop in tracing sheets, you will put in topo sheets, topo table, and integrate. So it is very critical. But in GIS, you just scan it, georeference it, all these will be superimposed exactly, then integrate it. It is very easy. Yes, Samita Gar, you want to know the difference between vector and raster. Already I have discussed, and I have discussed theoretically. In the hands-on class, again I will explain it so that you will be able to know. Because the Odisha map I have given to you, you just zoom it. The road, if you will view after zooming it, the road you will view after zooming it, it will be cracked into pixels or grids. So that is the concept of a raster. And in case of vector, I will draw a line in QGIS. You will be doing. You will be developing a linear layer, line layer, point layer, and polygon layer. You zoom it, there will be no crack. It is very precise, and it will be having a table associated with it. So this is the concept of a vector layer. Yes. And Prabhuswamy, is there any use of raster image if an equivalent vector image is already available? If vector layer is available, there is no use of raster image. Yes, sometimes it is required to rasterize the vector layer also. Why? Because if you have Arcgis imaging software and you have satellite images with you, you want to put a district map which is already with you in a vector layer form. You can convert it into raster and superimpose in the Arcgis imaging on the satellite image. Clear? What is redundancy? It is a data structuring internal matter. I am not going in detail. Actually, this is not a computer. Actually, due to the this is a 5-day course program. We are not entering in detail into the technicalities. I'm just giving you. Redundancy refer to the data internal structuring system. So, as I have already told you, the attribute data is getting structured in terms of a hierarchical model or network model or relational database model. In relational database model, the redundancy is very less. Anybody? Any other query?
What is the redundancy?
Is it clear?
Sir, what is the accuracy, sir, for conversion of vector to
chat
raster?
form is not audible. Please switch off the microphone. Please switch off the microphone and put it in the mute the microphone and put it the query in chat.
Hello?
Yes, Santosh Kumar, you have put the query accuracy of raster to vector conversion. Yes, when it is required, we do it. But it depends upon, again, I have told you, from raster to vector. Vector is definitely more precise, more accurate than the raster. But if you will convert as per your requirement, you can choose a balance between the accuracy as well as the files. If your system is too good, your hardware and software is too good, you can select higher resolution in raster by choosing a small grid size. Manojan Samuel, again, you have put the redundancy, isn't it clear? In fact, redundancy, I'm not going in detail because redundancy refers to a database management system internal matter. So, however, yes, nursing shed, use of GIS in flood control, definitely. We have certain application sessions also. We have lecture sessions in following days in which in the applications we will be discussing in various applications like disaster management, like healthcare planning, particularly in Odisha, how COVID management is going on. So in flood control, GIS is having a great application. Like if your district collector requires, if your state water resource secretary will tell you that yes, in particular area flood has happened, and what are the villages inundated, because I will not deploy the resources to all the villages in your district. What are the villages under flood? So you can take a village map of your district, you can take a flood inundated map of from satellite images, and you can overlay, superimpose them both, so that you can identify what are the exact villages which are inundated, which are under flood. Clear? Yes, Santosh Kumar, is an analysis is possible with raster to vector conversion. In raster, analysis is also possible. In vector, also analysis is possible. But whatever the softwares we are using right now, these are the vector software, so vector analysis is possible. Yes, raster analysis software is there. Arcgis Imagine, I have told you. ERDAS, Arcgis Imagine. In that, raster analysis is very much feasible. So thank you all. It is now 11:30. We'll take a break of 30 minutes. Then we'll start at 12. Then we'll start at 12, right? Sir, 12. We'll join again. Thank you all.